ఇంటర్మీడియట్ విద్యారంగంలో అగ్రగామి మన NSR ఇంపల్స్ ఎడ్యుకేషన్ ఇన్స్టిట్యూషన్. ఐఐటి జేఈఈ అయినా నీట్ అయినా తిరుగులేని విద్యా సంస్థ NSR ఇంపల్స్.
Balancing redox reactions. Methods to balance redox reactions or chemical equations. There are two methods, but why we have to balance? First thing, a balanced chemical equation. A balanced chemical equation provides conservation of atoms, conservation of mass and conservation of charge. A balanced chemical equation conserves atoms, conservation of mass and conservation of charge. These three you have to take care. Alright. So that is, it is based upon this conservation of atoms, conservation of mass, conservation of charge. So there are two methods. One we call it as oxidation number method. Oxidation number method, and the second one is half reaction method or ion electron method. Half reaction method. So there are certain basic rules on which we are going to solve them. So let us see one by one. The first one, oxidation number method. So what we have to do in oxidation number method? Oxidation number method. Let us see the rules. First one, you have to write the correct formula for reactants and products. Write the correct formula of reactants as well as products. That is the first step. Second step, assign oxidation numbers to all atoms. Assign oxidation numbers to all atoms. Next, after assigning, then you can clearly identify the species that undergoes oxidation and the species that undergoes reduction. Calculate the change in oxidation per atom and molecular ion for both oxidation as well as reduction. Calculate the change in oxidation per atom and molecular ion. Right? You have to calculate the change in oxidation state for both oxidizing as well as reducing agent. Then the number of units change in oxidation must be equal to number of units change in reduction. Before this you can balance atoms if it is possible, right? Next you have to check whether the number of units change in oxidation is equal to number of units change in reduction. If it is not equal, then multiply oxidizing agent with number of units change in oxidation and reducing agent with number of units change in reduction. Then they become equal, right? So balance all atoms other than oxygen and hydrogen. After balancing all atoms, then go for oxygen and hydrogen. So how to balance oxygen and hydrogen? First check whether it is acidic medium or basic medium. In which medium the reaction is carried out. So it plays important role here. Now to balance hydrogen in acidic medium, add H plus ions. You have to add H plus ions wherever necessary as much as required. To balance oxygen in acidic medium, add water wherever necessary as much as needed. You can repeat these steps number of times. Coming to basic medium, to balance hydrogen in basic medium, you have to add water wherever necessary. To balance oxygen, you have to add OH minus in basic medium. So let us recollect once again oxidation number method. Write the corrective formula for reactants and products. Then assign oxidation state for all atoms. Identify the species which undergoes oxidation and reduction. Third one, calculate the change in oxidation state per atom and molecule or ion. Right? Try to balance those atoms by hit and trial method. Then the number of units change in oxidation must be equal to number of units change in reduction. If this is not observed, then multiply oxidizing agent with number of units change in oxidation and reducing agent with the number of units change in reduction. We are multiplying with suitable number so that number of units change in oxidation must become equal to number of units change in reduction. Then balance if there are any other atoms which are not balanced by hit and trial method. By adjusting the coefficient you can balance other atoms except oxygen and hydrogen. To balance hydrogen and oxygen you have to see whether it is acidic medium or basic medium. To balance hydrogens in acidic medium, add H plus ions wherever that is necessary, right, on proper side by adding H plus ions. To balance oxygen you have to add an acidic medium, you have to add water, right. So to balance hydrogen in basic medium you have to add water. To balance oxygen in basic medium you have to add OH minus. You can repeat this as many times as required till all hydrogens and oxygens are balanced. So let us do some problems on this. Let's try to balance this equation. Write the net ionic equation for reaction of potassium dichromate and sodium sulfate in an acidic solution. That means medium is acidic. So potassium dichromate, the chromium is changing from +6 to +3 and sulfite is changing to sulfate. So this is the equation given. So if I write the ionic equation, write the correct formula. Potassium dichromate K2Cr2O7 plus sodium sulfite Na2SO3 gives chromium +3 ions and sulfate ions SO4 -2. So let us remove the spectator ions. What are spectator ions? The ions which do not undergo either oxidation or reduction. So identify potassium and sodium, they belongs to first A. Potassium and sodium, they belongs to first A. In their compounds, in their combined state, they always show +1 whether they are present on reactant side or product side. So they do not undergo any change in oxidation. We can remove them. We can call them as spectator ions. So if I remove 2 potassium, 2K plus, the charge left over will be Cr2O7 minus 2, Cr2O7 minus 2. If I remove 2 sodiums, left over charge will be -2, SO3 minus 2 gives chromium +3, SO4 minus 2. So it has a net charge ion -2, it has a net charge -2, it has a net charge +3, it has a net charge -2. Right. So we have written the corrective formula for reactants and products. Write the corrective formula for reactants and products. Next, assign oxidation state. We have to assign oxidation state. So I am writing once again Cr2O7 -2, SO3 -2, right. So chromium oxidation state. If you don't know, this is the procedure. This is ion. Sum of the oxidation state of all atoms must be equal to charge on the ion. So we don't know chromium. This is chromium oxide. In oxide, oxygen carries -2. So oxidation state of oxygen in oxide is -2. Chromium we don't know. Let us assume X. How many chromiums are there? 2. So 2 into X. Sum of the oxidation numbers. 7 oxygen into its oxidation number -2 equal to -2. Charge on the ion is -2. Sum of the oxidation state of all atoms in this ion must be equal to charge. So 2x -14 equal to -2, 2x equal to 12, x equal to +6. That is what it is given here. What? 6. So oxidation state of chromium is plus 6, oxygen is minus 2. Similarly, sulfite. We don't know sulfur, let us assume X. Oxidation state of sulfur is X. Oxygen minus 2, this is oxide. So net charge is minus 2, that means sum of the oxidation state of all atoms must be equal to minus 2. So how many sulfurs? 1 into its oxidation state X. How many oxygens? 3. Its oxidation state must be equal to minus 2. X minus 6 equal to minus 2. X equal to 6 minus 2, that is equal to plus 4. So sulfur is plus 4, oxygen is minus 2. Chromium, there is only one atom, one ion. The charge on the ion itself will be its oxidation state. Sulfate, we don't know the oxidation state of sulfur. So oxidation state of sulfur, let us assume X. Oxidation state of oxygen, anyway it is minus because it is also oxide. Sum of the oxidation state of all atoms, 1 sulfur, 4 oxygen must be equal to minus 2. 1 sulfur into its oxidation state, 4 oxygen into oxidation state equal to minus 1. X minus 8 equal to minus 2. X equal to 8 minus 2, that is equal to plus 6. So sulfur plus 6, oxygen minus 2. So assign the oxidation state of all atoms. Then identify the species which undergoes oxidation reduction. Now, change in oxidation state, oxidation number, change in oxidation number of chromium atom. What is the oxidation state of chromium atom? Plus 6. Changes to plus 3. So there is a 3 units decrease. 3 units decrease. Change in oxidation number of dichromate ion or per dichromate. In one dichromate ion there are 2 chromiums. Each chromium has an oxidation state of plus 6. For 2 chromiums it will be plus 2 per dichromate. Per dichromate means one dichromate ion contains 2 chromium. For each chromium it is plus 6. For 2 chromium it will be plus 6. 2. Here you should not consider 1 chromium, you have to consider 2 chromium. They are reduced, both reduced to plus 3. So 2 into 3, 6. So total is 6 units decrease. So dichromate undergoes reduction. Therefore, it acts as oxidizing agent. It acts as oxidizing agent. Coming to next, sulfur. Sulfur. Change in oxidation state of sulfur. Oxidation number of sulfur. Sulfur changes from plus 4 to plus 6. That means 2 units increase in oxidation number. Here one ion contains 1 sulfur. So per sulfur or per ion will be same because it contains only 1 sulfur. Change in oxidation number of per sulfate ion SO3 minus 2 ion is 2 units increase. Therefore, SO3 minus 2 undergoes oxidation or sulfite ion acts as reducing agent. So this is the information we can gather. So number of units change in reduction is 6. Number of units change in oxidation is 2. Are they same or different? Before that, We can balance chromium. There is one sulfur, but here for one ion you have two chromiums. You can balance here, you can write 2 here. So balancing that, atoms which undergo the change by normal hit and trial method. So Cr2O7 minus 2 plus SO3 minus 2 gives. So here 2 chromium, I am writing 2 here so that we can balance it, plus sulfate ion. Now, number of units change in oxidation is 2 units, number of change in reduction is 6 units. Are they same? They are not same. One is 6 units and other is 2 units. We have to make them same. What we have to do? We have to make this as 6 units. How to make this as 6 units? Multiply this entire sulfate ion with 3. So, for 1 mole there is 2 units loss. For 3 moles there will be 6 units increase, right. So, the number of units in oxidation will become equal to number of decrease in reduction. For that we have to multiply sulfate ion with 3. So, adjusting the coefficient to make number of units decrease in oxidation equal to number of units increase in oxidation. So, we have to make this 6. To make this 6 we have to take 3 moles. (3SO3 minus 2 chromium plus 3), then you will get 3 sulfate ions. Now, the number of units decrease in oxidation must be equal to number of units increase in oxidation. Both are same. Now, try to balance any other atoms if there are 2 chromium other than oxygen and hydrogen, 2 chromiums, 3 sulfurs, 3 sulfurs. So, except oxygen and hydrogen, all other atoms are balanced. Then we have to go for oxygen and hydrogen. There is no hydrogen. So, let us try to balance oxygen first. Now, which medium it is? Acidic medium. So, how many oxygens we have on this side? So, recollect, to balance oxygen, so I am erasing this. Which medium we have here? Acidic medium, right? So, in acidic medium, to balance hydrogen you can use H plus, to balance oxygen you can use water. Let us count oxygens on left hand side. So, here we have 7 oxygen atoms, 3 into 3 9 oxygen atoms, 7 plus 9, right, 7 plus 9 total 16 on left hand side. Coming to this, 3 into 4 12 oxygens. We have 12 oxygens, here we have 16. Where you have deficiency? On the right hand side. How many? 4 oxygen atoms. 4 oxygen atoms. So, to balance oxygen atoms in acidic medium we have to use water. How many water should I add? If I add 1 water, 1 oxygen atom will increase. We require how many such oxygens? 4. So, I have to add 4 oxygens on the right hand side. Adding water on the right hand side. H2O. Now you can count oxygens. 7 plus 9 16, 3 4s are 12 plus 4 16. Because of addition of water, the number of hydrogens are added. How many hydrogens? 4 into 2, 8 hydrogens. 8 hydrogens are more on which side? Right hand side. Therefore, to balance hydrogen we have to use H plus. Where you have deficiency? On left hand side. So, add H plus ions. How many? 8 H plus ions on the left hand side. You can repeat these steps as many times as possible till they are completely balanced. Cr2O7 minus 2, 3SO3 minus 2, 8H plus gives 2Cr plus 3, 3SO4 minus 2, 4H2O. So 2 chromiums, right, 3 sulfurs, 3 sulfurs. Do not alter chromium sulfur again once they are balanced. Next, 8 hydrogens, 4 into 2 8 hydrogens, 7 plus 9 16 oxygens, 3 into 4 12 plus 4 16 oxygens. So atoms are balanced, you can find mass, it will be balanced. So if you see charge, 8 protons, 8 positive charge, 3 into 2 6, 7 8, 8 negative charge, 8 positive charge, cancelled out. So net charge will be 0, 2 into 3 6 positive charge, 3 into minus 2 6 negative charge. So charge is also balanced. Next one, permanganate ion reacts with bromide ion in basic medium. So we are taking one example for basic medium to give manganese dioxide and bromate ion. So here you should be in a position to write the formulas of the ion. Permanganate ion, potassium permanganate. So permanganate ion means MnO4 minus, bromide ion, that is Br minus, gives manganese dioxide MnO2, of course, basic medium Bm, basic medium, manganese dioxide, sorry, MnO2, right, bromate, so BrO3 minus. So these are the corrective formulas for reactants and products. So we have written the first step, write the corrective formula for reactants and products. What is the next step? Assign oxidation states. So I am writing once again. So let us find our normal method. So in MnO4 minus, let oxidation state of manganese, we don't know, so let us assume X. It is oxide of manganese, so oxygen oxidation state will be as usual, it is minus 2. So sum of the oxidation state of manganese, 4 oxygen must be equal to negative charge. So 1 manganese, 1 into X, 4 into minus 2 equal to minus 1. So X minus 8 equal to minus 1, X equal to 8 minus 1, that is 7. So manganese oxidation state is plus 7, oxygen oxidation state is minus 2. Right, here Br minus, so clearly we can see its oxidation state must be minus 1. Coming to MnO2, if you don't know the same procedure, oxidation state of manganese, let us assume X, oxide, therefore oxygen shows minus 2. How many manganese? 1. Sum of the oxidation state must be equal to 0, no charge. 1 into X, 2 into minus 2 equal to 0, X equal to plus 4. So manganese oxidation state is plus 4, oxygen oxidation state is minus 2. Already we have calculated this in the last class, but still let us find. Oxidation state of bromine we don't know, so let us assume it as X. Oxygen minus 2. Sum of the oxidation state of bromine and 3 oxygen must be equal to minus 1. So 1 into bromine, that is oxidation state of bromine X, 3 into oxidation state of oxygen minus 2 equal to minus 1, X minus 6 equal to minus 1, X equal to 6 minus 1, that is plus 5. So bromine plus 5, oxygen minus 2. So these are the oxidation states. Assign the oxidation states. After assigning, calculate the change. Next step, change in oxidation state. Oxidation state of manganese. See here, +7 to +4. +7 to +4. That means 3 units decrease. So, one permanganate contains one manganese. So, change in oxidation state per molecule per permanganate ion equal to 3 units decrease. That means it undergoes reduction, therefore acts as oxidizing agent. Next, bromine. -1 to +5, -1 to +5, that is 6 units increase. -1 to 0, 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5. So, total 6 units increase. Change in, so only one bromine, oxidation state per bromide ion is same, 6 units increase, therefore it undergoes oxidation and acts as reducing agent. So, number of units, one manganese, they are balanced, one bromine, they are balanced. So, other than oxygen, remaining atoms are balanced. Now, let us see change in oxidation state is same or not. So, number of units change in oxidation, here it is 3 units, number of change in oxidation, here it is 6 units. Are they same or different? They are different. They must be made equal. How to make them equal? How to increase it to 6? How to increase it 6? I have to take 2 moles. I have to multiply this with 2. For 1 mole 3 units decrease, for 2 moles 6 units decrease, then these two will be equal. So, multiplying permanganate with 2. So, what I will get? 2 MnO4 minus plus Br minus gives right. So, we have balanced all atoms other than oxygen and hydrogen. We have even balanced the change in oxidation states for both oxidizing agent and reducing agent. Then we have to balance oxygen and hydrogen. For that you have to see medium. What is the medium here? Basic medium. So, basic medium to balance hydrogen, to balance oxygen. To balance hydrogen, I have to add water. Balance oxygen, you have to add OH minus wherever required. So, there is no hydrogen. Let us balance oxygen. Count oxygens. 2 into 4, 8 oxygens. 2 2s are 4 plus 3, 7 oxygens. So, we have one oxygen atom less on the other side. So, add OH minus, one oxygen is less, therefore, adding one OH minus. On the other side, wherever there is deficiency. So, oxygen is balanced, but addition of OH resulted in increase in the hydrogen. To balance hydrogen, again I have to add water. I have to add water. So, addition of each OH will increase one hydrogen. Addition of each OH will increase 1 hydrogen. So what I have to do is, if I add water here, again 1 oxygen will be increased. So again I have to add OH. Therefore, to avoid this repetition, for every addition of OH minus, add 2 OH here, on the opposite side add 1 water. Right. What we have to do is add water, 1 molecule of water on the same side, and 2 molecules of OH on the opposite side or proper side for every excess of 1 oxygen. Here you have 1 oxygen atom excess, therefore add water here. On the other side add 2 OH minus. For 1 water you have to add 2 OH minus. So what I am doing is I am adding 1 water here. For 1 water I have to add 2 OH minus. So 2 oxygens are increased, on the other side you have 1 oxygen, so oxygen is balanced. 2 hydrogens, hydrogens are also balanced. Let us check. So if you have oxygens excess, right, where on the side wherever you have excess oxygen, add 1 water molecule on the excess side. On the opposite side add 2 OH minus for every excess oxygen atom. Now let us check. 2 manganese, 1 bromine, 1 bromine. Hydrogens, 2 hydrogens, oxygen 2 into 4 8 plus 1 9 oxygens, 2 2s are 4 plus 3 7 plus 2 9 oxygens. Even charge 2 moles, so 2 negative charges, here 1, total 3 units of negative charge. Here 1 unit negative charge, here you have 2 units negative charge, total 3 units of negative charge. So it is balanced. Let us do some problems. Write the oxidation number of mercury in amalgam. First, what is amalgam? A metal dissolves in another metal. A metal dissolves in another metal. Say sodium dissolved in mercury, mercury amalgam, sodium amalgam. Zinc dissolves in mercury, zinc amalgam. So sodium dissolves in mercury, NaHg. This is the formula. Zinc dissolves in mercury, ZnHg. ZnHg. So one metal dissolves in another metal, they do not chemically react, there is no loss or gain of electrons. So they are present in their elemental state. So whether you take amalgams or metal alloys, alloy is also mixture of 2 or more metals. The oxidation state of the metal is 0. So here mercury oxidation state is 0. Amalgam is mixture of 2 metals, sodium amalgam, sodium mercury, zinc amalgam, zinc mercury. 2 metals are dissolved together, they do not react. There is no gain or loss of electrons. Hence the oxidation state of metals, right, or mercury in amalgam is 0, or in alloys. Alloy is also mixture of 2 or more metals. So there also there is no loss or gain of electrons. Hence in alloys and amalgams the oxidation state of metal is 0. Coming to the next one, 1 mole of AO2 minus is oxidized to A plus N in acidic solution. 0.4 moles of by 0.4 moles of permanganate. So permanganate oxidizes, AO2 minus is oxidized by permanganate ion in acidic medium to A plus N. A plus N. So first let us find the oxidation state of A here, we do not know. So oxidation state of A, let us assume it as X. Oxidation state of oxygen, that is -2. So only one A is there, so 1 into X, 2 into -2 equal to -1, X minus 4 equal to -1, X equal to 4 minus 1, that is +3. Right. So in acidic medium, MnO4 minus changes to Mn plus 2. This we have to know. That means manganese changes from +7 to +2. That means there is a change of gain of 5 electrons. 1 mole will give 5 electrons, but actually how many moles? 0.4 moles. If 1 mole can gain 5 electrons, 0.4 moles can gain 2 moles of electron. Who is giving these 2 moles of electron? AO2 minus. So AO2 minus. What is the change in oxidation state? Okay. So plus 3 to plus n. What is the change? N minus 3. Here it is plus 3, here it is n. So plus n. What is the change? Here what we do here? 7 minus 2, 5 electrons. It is gaining 5 electrons. Here it is 1 mole is losing n minus 3 moles of electron. 1 mole of A minus 2 loses n minus 3 electron. This much electron is gained by 0.4 moles of electrons. Here 1 mole gains, 1 mole of MnO4 minus gains 5 moles of electrons. But here actually how much is reacting? 0.4 moles. How much? That is 0.4 into 5. 2 moles of electrons. This 2 moles of electron is provided by n minus 3 moles of electrons, last by 1 mole of AO2 minus. So n minus 3 equal to 2, n equal to 3 plus 2 equal to 5. Next one, 1 mole of hydrogen. What is hydrogen? N2H4. So if you find the oxidation state, minus 2 of nitrogen. It loses 10 moles of electrons. How many moles? Into some compound of nitrogen. So 1 mole contains 2 moles of nitrogen atoms. All these nitrogen atoms are present here. We don't know its oxidation state. So let oxidation state of a nitrogen atom is X. There are 2 nitrogens. So oxidation state of 2 nitrogens becomes 2X. Right. So from here to here, how many moles of electrons are lost? 2 moles. So the difference in oxidation state must be equal to 10 moles of electrons. So 1 nitrogen oxidation state is X for 2 nitrogens, because both are present in the same species. For 2 nitrogens, 2X. All nitrogen content is present in the product. So here 2 nitrogens are there, same 2 nitrogens will be present, but with the different oxidation state, which we have to find, 2X. So the difference of these two, 2X minus 2, that is 2 into minus 2 equal to 10. 2x minus 4 equal to 10. 2x equal to 14. Sorry, this is plus 4. Plus 4. Here 10 minus 4, it is 6. X equal to plus 3. So the oxidation state of nitrogen is plus 3. For 2 nitrogens, plus 6. Minus 2, minus 3, sorry, minus 1, 0, 1, 2, 3. So 1 electron, 2 electron, 3 electrons, 4, 5. So 5 electrons per nitrogen. For 2 nitrogens, 5 plus 5, 10 electrons. So the change in oxidation state should be from minus 2 to plus 3.
ఇంటర్మీడియట్ విద్యారంగంలో అగ్రగామి మన ఎన్ఎస్ఆర్ ఇంపల్స్ ఎడ్యుకేషన్ ఇన్స్టిట్యూషన్. ఐఐటి జేఈఈ అయినా నీట్ అయినా తిరుగులేని విద్యా సంస్థ ఎన్ఎస్ఆర్ ఇంపల్స్.